The oral floor includes all the soft parts, which constitute the lower limit of the oral cavity. It is shaped like a quadrangular pyramid, with its summit forward and its base rearward. Limiting the floor are supporting bones, such as the jaw forward and the hyoid bone rearward. The mylohyoid muscle, running from the mandible to the hyoid bone, divides the floor in two parts, superior and inferior, which communicate on the posterior edges. It participates physiologically to processes such as digestion, phonation, and saliva secretion. Yet, it can be subject to pathologies, including lesions, tumors, or infections. The mandible, horseshoe-shaped, its concavity facing rearwards, consists of three parts. First, the lower part, or body, which consists of two symmetrical halves welded to the chin by a suture called the mandibular symphysis. Then, two rami, right and left, composed of a vertical part called the rising branch and a horizontal part called the horizontal branch. The upper end is formed by the condylar process behind, belonging to the temporomandibular joint, and by the coronoid process in front. The bone in which the teeth are implanted is called the alveolar bone, as opposed to the very bone structure of the mandible called the basal bone. Localized between the larynx and the mandible, next to the fourth cervical vertebra, the hyoid bone is horseshoe-shaped, its convexity facing forwards. Its different parts are the body central part, whose anterior side is marked by the median tubercle, two greater horns on each side of the body extending upwards dorsally, two lesser horns, conical, between the body and the greater horns, extending upwards. The oral floor is composed of three structures: a muscular diaphragm, formed by both of the mylohyoid muscles, filling the space between both of the mandibular rami. Then, two geniohyoid muscles above the diaphragm. Finally, above aforesaid, the tongue. Between the three muscles are two glandular lodges. First, the sublingual lodge, and then the submandibular lodge. Mylohyoid muscles, pure, thin, and symmetrical, form a muscular diaphragm shaped like a posterior base triangle. The aforesaid forms the oral floor's inferior limits. Both muscles are united on the median line by the median raphe. They contribute to supporting the floor, elevating and towing forwards the hyoid bone and the larynx during deglutition. They lower the mandible when the hyoid bone is fixed. We also have two geniohyoid muscles, symmetrical, juxtamedian, and united on the median line by a septum, located above the mylohyoid and under the genioglossus muscles. It can elevate and pull the hyoid bone forwards and also works with the mylohyoid to lower the mandible and open the mouth. The digastric muscle is formed by two bellies, one anterior and one posterior, linked by an intermediate tendon attached to the hyoid bone's body. The muscle has different actions depending on which bones constitute the fixed point. When the mandible is fixed, it elevates the hyoid bone. When the hyoid bone is fixed, the digastric muscle opens the mouth by lowering the mandible. To complete the oral floor's inferior limits, the posterior border of the mylohyoid forms, alongside superior and medium constrictor muscle, a great opening in which proceed structures associated with the tongue. The oral floor contains several salivary glands, such as major ones, sublingual and submandibular glands, which are pure and symmetrical, and minor ones, subepithelial accessory glands. Sublingual glands are the smallest of the three principal salivary glands. They are flattened transversely and elongate. Located inside the oral floor, under the mucous membrane of the alveololingual sulcus or sublingual fold, they are composed by an agglomeration of around 20 glandular lobes. Principal excretory canals are Rivenes's canals, and accessory excretory canals are Walther's canal. They go along Wharton's canals, coming from the submandibular glands, and confer near the oral floor, in front and outside of the salivary wattles. Sometimes, several ducts can join to form a common duct, named Bartholin Canal, which generally empties in the principal submandibular conduct. They are smaller than the parotid glands, but bigger than the sublingual glands. Elongate, they are shaped like an almond, extended by its excretory canal. They are located under the mandible's angle and body, paramedian, under and outside the mylohyoid muscle, in the superficial cervical fascia split, like a creole in her hammock. Wharton's canals, secreting saliva, emerges from the median side of the gland's deep part, in the oral cavity, and travels onward to open itself at the summit of a small sublingual papilla, next to the base of the lingual brake and the lingual caruncula. The lingual nerve will cross the median and lateral sides of the conduct, traveling at a loop under a forceps before riding up to the tongue. The submandibular gland can be dug by the facial artery. It is palpable by a bidigital touch, just as most elements of the oral floor. General sensory input comes from the trigeminal nerve's lingual branch, with, in particular, the input from the chorda tympani branch, coming from the facial nerve. The mylohyoid muscle is innervated by the mylohyoid nerve from the mandibular nerve. The digastric muscle's anterior belly is also innervated by the mylohyoid nerve. The geniohyoid muscle is innervated by an anterior branch of C1 transported along the hypoglossal nerve. The sensory innervation of the salivary glands is provided by the mandibular nerve, and the efferent innervation is ensured by the autonomic system via the chorda tympani and the submandibular ganglion. The lymphatic system removes metabolic waste and implements the immune response with the production of antibodies. The vessels drain into the submental, submandibular, and jugular digastric nodes. Then, they gather at the deep cervical lymph nodes. This part will be more detailed in the next chapter concerning the hemorrhagic risk in dental implantology. For now, let's just say that the oral floor is mostly irrigated by the sublingual artery, which ends with the maxillary and the chin branch, and by submandibular branches of the facial artery, both coming from the external carotid artery.